Welcome to PRISCI-ANTO Educational Academy. Today we are going to study the exponential distribution. So definition of exponential distribution is f of x is equal to lambda into e power minus lambda x, where x is greater than 0. Example of exponential distribution is the car tire. If you purchase the car, we are using for 4 years, 5 years, the tire will be, there will be depreciation in a tire. So this is called as, this is the example of exponential distribution. E power minus x. E power plus x is the increasing function. For example, the necessity of milk in the morning is 1000 liters per day. In the festival season, it will increase, it will be increased because many people will come. So it will be increased. So this is the plus e power x example. So moment generating function mx of t is equal to expectational of e power tx. Integral, this is the exponential distribution, is the continuous distribution. So integral e power tx f of x dx. Integral over the limit x is greater than 0. That's why we are taking lower limit 0, upper limit infinity. E power tx lambda e power minus lambda x into dx. So lambda into integral over the limit 0 to infinity e power minus of lambda minus t into x into dx. Lambda into, you have to integrate it, e power minus of lambda minus t into x divided by the coefficient of x minus of lambda minus t. Limit is 0 to infinity. So for x, you have to apply the limit to infinity minus, for x, you have to apply the lower limit 0. So lambda into e power minus infinity divided by minus of lambda minus t minus e power 0 divided by minus of lambda minus t. First term e power minus infinity will be 0. So first term will vanish. E power 0 will be 1. So minus of minus plus. So 1 into lambda, lambda, lambda divided by lambda minus t. So moment generating function is lambda divided by lambda minus t. So next, this lambda divided by lambda minus t can be written as numerator is lambda, denominator lambda minus t. If you are taking in the denominator lambda as a common element, lambda into 1 minus t by lambda. Numerator lambda, denominator lambda will be cancelled. So 1 divided by 1 minus t by lambda. This 1 divided by 1 minus t by lambda, 1 minus t by lambda, it is in the denominator. If it goes to numerator, mu x of t, which is equal to mx of t is equal to 1 minus t by lambda whole inverse. So you can expand using the formula 1 minus x whole inverse. 1 minus x whole inverse is equal to 1 plus x square plus x cube plus etc. So 1 minus t by lambda whole inverse is equal to, using this formula, 1 plus t by lambda whole square plus t by lambda whole cube plus etc. So mu x dash of t is equal to mx of t is equal to 1 plus 1 by lambda into t. T by lambda can be written as 1 by lambda into t plus 1 by lambda into t square plus 1 by lambda cube into t cube plus etc. So mu 1 dash, which is equal to E of x, expectational of x, which is equal to mean, which is equal to the coefficient of t divided by 1 factorial. What is the t divided by 1 factorial? T divided by 1 factorial is 1 by lambda. That is the coefficient. So that is the mean. So E of x is equal to 1 by lambda. Mu 2 dash, which is equal to the coefficient of t square divided by 2 factorial. What is a t square divided by 2 factorial? Here is a t square divided by 2 factorial. There is no 2 factorial. That's why I am multiplying and divide by 2 in this term. T square divided by lambda square. I am multiplying by 2 and divide by 2. So that's why 2 by lambda square. T square by 2 factorial is 2 by lambda square mu 2 dash. I have written here t square by 2 factorial is equal to t square by lambda square is in the formula. So multiply and divide by 2. So t square divided by 2 factorial coefficient is 2 by lambda square. So that's why I have written here 2 by lambda square. Variance is expectation of x square minus expectation of x whole square, which is equal to 2 by lambda square minus 1 by lambda whole square will be 1 by lambda square. So 2 by lambda square minus 1 by lambda square will be 1 divided by lambda square. This is variance, right? This is variance. So in another way also you can find mean is equal to E of x, which is easy, you can adopt it, you can follow it. Mean is equal to expectation of x is equal to integral x into f of x dx. What is f of x? From the definition of exponential distribution, integral over the limit 0 to infinity x into lambda into e power minus lambda x into dx. So lambda integral over the limit 0 to infinity x into e power minus lambda x into dx. So this can be solved using the Bernoulli's formula. Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3. U dash, u double dash, u triple dash, these are differentiation. v1, v2, v3 are called integration. So u is x. U dash is x. If you are differentiating one time, you will get 1. U double dash is 1, you have to differentiate another time. So it will be 0. V is equal to e power minus lambda x. V1 is equal to e power minus lambda x divided by minus lambda. You have to integrate it. Integration means x coefficient you have to write in the denominator. So e power minus lambda x divided by the coefficient of x is minus lambda. So that's why v1 is equal to e power minus lambda x divided by minus lambda. Again you have to integrate, that is called as v2. So e power minus lambda x divided by, already there is minus lambda, again one more minus lambda will come. So e power minus lambda x divided by minus lambda into minus lambda will become as lambda square. So v2 is equal to e power minus lambda x divided by lambda square. Now you have to apply in the formula. So E of x is equal to lambda into uv1 x into e power minus lambda x divided by minus lambda. Formula minus u dash 1 v2 e power minus lambda x divided by lambda square. Limit is 0 to infinity. So lambda into x into e power minus lambda x divided by minus lambda minus e power minus lambda x divided by lambda square. Limit is 0 to infinity. For x, you have to apply upper limit to infinity. If you apply both term will become 0 because e power minus infinity, the value is 0. So therefore, okay, so therefore lambda into, okay, so when you apply the lower limit, first term will become 0, second term will be e power 0 divided by lambda square. So lambda divided by lambda square. E power 0, 1. So minus of minus e power 0 plus e power 0 divided by lambda square. So lambda divided by lambda square, which will become, which is equal to 1 by lambda. This is E of x, expectational of x. E of x square is equal to, expectational of x square is equal to x square into f of x dx. Integral over the limit 0 to infinity x square lambda into e power minus lambda x, lambda into e power minus lambda x into dx. So lambda into integral over the limit 0 to infinity x square e power minus lambda x dx. Again, you got to use the Bernoulli's formula. U is equal to x square. V is equal to e power minus lambda x. U dash 2x. U double dash 2. U triple dash 0. These are differentiation. V1 integration e power minus lambda x divided by minus lambda. V2 e power minus lambda x divided by lambda square. V3 e power minus lambda x divided by minus lambda 3. So using the formula lambda into uv1 x square e power minus lambda x divided by minus lambda. Formula minus u dash v2 2x into e power minus lambda x divided by lambda square plus u double dash v3 plus 2 into e power minus lambda x divided by minus lambda 3. Limit is 0 to infinity. When you apply the upper limit, every term will become 0. 3 terms will become 0. When you apply the lower limit, first 2 term will become 0. Last term will be minus of minus 2 e power 0 divided by lambda cube. So lambda into 2 divided by lambda cube, because e power 0 1. So lambda divided by lambda cube will become lambda square. So 2 divided by lambda square. This is expectational of x square. So variance of x is equal to expectational of x square minus expectational of x whole square, which is equal to 2 by lambda square minus 1 by lambda whole square. So 2 by lambda square minus 1 by lambda square, which is equal to 1 by lambda square. So there are two ways to find the value of mean variance.